This is paper 3, video 7 for the February mock. This is the first topic we're going to look at in this video. So we're given basically a distance time graph here representing depth and time of a fish in the ocean. And we are looking to find an estimate of the speed of the fish at different points. Now it's unlikely to be given 3 questions in the exam, but we've got 3 here just to do a bit of practice. In order to do a question like this, the speed is represented by the gradient of the curve at whatever time we are given. So for the very first one, what we'd have to do, at a time of 1 second, so the first thing we're going to do is just very quickly find 1 second and where it is on the graph. So it's around about there. To find the gradient, what we do, take your ruler and you are going to place it onto the line so as best as possible it follows the curve of the line and it passes through the point that we've just highlighted when time is 1. So something that looks a bit like that. Almost as if you were trying to place a piece of wood onto the curve. What we then do is try and find the gradient of that line. Now in order to do that, we do a little triangle so we can read off some values. So you can pick any square that you want as long as you can read information off that square. So I'm going to do here and here. You need to be quite accurate in the exam. Obviously, the scale that we've got on this paper isn't great. The one on the exam will be a lot more accurate. So if you remember, gradient is equal to the change in y divided by the change in x. Now for this first example, we're going to do 2 of them overall. For the first example, the change in y is the length of this line here. Now just quickly checking the scale, there are 4 squares for every one number, so that tells me each little square is 0.25. So we've got 1, 2, 3, 4, 5, 6 squares there, so 6 lots of 0.25 is 1.5. Going across the bottom, you've got 5 little squares for each number, so each little square would have to be 0.2 to make it up to 1. So if each little square is 0.2, we've got 1, 2, 3, 4, 5, 6, 7, 8 squares going along in this little triangle, so that would give us 1.6. 8 lots of 0.2, 1.6. So to find the gradient, we do the change in y, so this vertical distance here, which is 1.5, divided by the change in x, so this horizontal distance here. If you type into your calculator 1.5 divided by 1.6, it gives us the gradient, which in this case is 0.9375. I'm going to do one final example. You can have a go at the second one yourself. I'm going to do part C, which is at 5 seconds. So the exact same idea, we quickly find where 5 seconds is on the graph, like so. Take your ruler, and we are going to try and place that so it follows the rough curve of the graph, so somewhere about there, and draw your line on so that it just touches the point and just rests onto the graph. We do the same thing, picking any 2 points, as long as I can read them off quite easily. I can pick any points I want. I'm going to go for there and here. To try and draw a little triangle that looks a bit like that. Now I'm going to do the same thing, change in y, so that's this side, divide by change in x, so it's this one here. So the change in y, remember, each little square was 0.25, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, about 9 squares there. 9 lots of 0.25 is 2.25. And on the bottom we're going up in 0.2s, so 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, and probably 1.8 there. So to find the gradient at this point, I do the change in y, which was 2.25, divided by the change in x, which in this case is 1.8, and that gives me a gradient of 1.25. Now in terms of speed, we need some units for that. So speed, remember, this is very important for the exam. The distance was in metres, the time was in seconds, so both speed units are going to be metres per second, to give us something that looks like that. The next topic we've got is to try and find the turning points of some graphs. Now it's given us a suggestion here that we need to try and complete the square. Completing the square is a topic that you've not yet seen. Don't worry, you can go through this with your teacher after the mock. But very quickly, just to show a quick technique for completing the square. Again, I'm going to fit 2 on this page probably. So the first one, x squared plus 4x minus 12. What I need to do is I need to come up with a bracket that gets very close to equaling this when I square it. Hence why this is called completing the square. Well, to get very close, I would need an x in the bracket, because then x times x will give us the x squared. And whatever number is in front of the x, if you put half of that inside the bracket. The reason we've done this and picked this particular one out is if I were to expand that, so if I did as a little side note, x plus 2 times x plus 2, this would give us x squared plus 2x plus 2x plus 4, which if I simplify and neaten up, gives us this. Now this little bracket is correct for the x squared part. It's got the same number in front of the x, it's only this little bit at the end that is slightly different. So what I do now is I try and think, what would I have to do to this to make it equal this? Well here, because that says plus 4, we want it to say minus 12, I would have to take 16 off here. If I were to do that, it would give me x squared plus 4x minus 12. But with this being a little equation, I'm going to do the exact same to the bracket. So it gives me x plus 2 squared minus 16. And the reason that we've done this is that this little section can now tell us the turning point of the graph. If you're not sure what the turning point is, if you remember, if I were to draw a graph like that, the turning point is simply the lowest point on the graph. So the turning point, very nice and simple. What value of x would make this bracket equal 0? Well, for that to equal 0, x would have to be minus 2, so that's the x coordinate. And whatever this number is outside the bracket, that's the y coordinate of our turning point. So here, we've found the turning point. If I do the same with the one at the bottom, and I'll leave the middle one for you to have a practice at, same idea again. I need a bracket that will get exceedingly close to looking like this when it's squared. So again, half of 10 is 5. This little tactic works. It's quite good for finding it very quickly. If I were to expand this bracket, so effectively I'm doing x plus 5 times x plus 5, because that's all squaring means. That gives us x squared plus 5x plus 5x plus 25. I'm going to neaten that up here. So it's x squared plus 10x plus 25. Now that's quite close to what I wanted it to be. X squared plus 10x minus 12, very close, it's just the plus 25 at the end that's a bit different. So what would I have to do to this to make it into this? Well, to get from 25 to minus 12, I'd have to take 37 off both sides. So if I'm taking 37 off this side to make it into x squared plus 10x minus 12, I would take 37 off this side, and I would write it as x plus 5 squared minus 37. Now the reason we've done this, the reason that completing the square is very good, is that this actually tells us quite easily the turning point. So the turning point would have to be minus 5, because that's the value of x that would make this bracket equal 0, and then it's whatever number is here at the end. If you want to have a little practice yourself and see if you get something similar, for this one here in the middle, x squared plus 8x minus 6, the final answer and the turning point would be minus 4 minus 22. If you get the same answer, brilliant. If not, check with your teacher and see where you might be making a slight mistake.